Hi, this is Joe Maciars from A Tutoring Enterprises. Today I want to do another Apple Grapher graphing calculator application, and we're going to talk about rational functions. Specifically, we're going to look at the degree of a polynomial function that's on the bottom and ask how does that affect something called vertical asymptotes. All right, just want to mention that we have a guest in the studio today. This is Cole. Cole, this is the world Cole. Go ahead and say hi.
You're so clever.
Yeah, I know. Anyways, let's go ahead and go over. I should mention Cole is one of my students, and he's trying to pass advanced algebra. So this is actually material that I'm trying to teach him, and we'll see if we can do that. Actually, I wanted to go over to. That was the wrong application. We're going to go over to this one here. All right, we're going to start off with a parameter. We're going to start with n equal 1. And today what we're going to do is we're going to study, the last video we looked at things like y equals x to the n, and we studied what happened with changing the n. Well, today we're going to look at something similar. It's going to be 1 over x to the n, except I'm going to move it over 2 units. By now you should know, if you've watched my videos, that changing x to x minus 2 is going to shift it 2 units to the right. Isn't that correct?
That's correct.
That's correct. All right, so let's go see what we've got going on here. Now, this is just going to end up being the inverse relation shifted over 2 units. So normally we would have first and third quadrants, and except that that whole thing has been shifted to the right 2 units. All right. Let's also put in the asymptote itself, which is going to be the equation x equals 2. All right, we're going to color some of these things so we can see them very clearly. All right. Cole, can you tell me what an asymptote is?
It is a line which is also like a value that the graph approaches but doesn't actually touch, but it comes so close that eventually you'll find a value where you'll just say, yep, we'll just call it x equals 2. It's close enough where we're going to call it x equals 2.
Well, actually, that's true for the horizontal asymptotes. For the vertical asymptotes, that part's not true. There's no real limiting value to this. There's no y value, because what's happening is, for example, this side is going to positive infinity. As we get closer and closer, as x gets closer to 2, what's happening is this green line is going off to infinity. So there's not going to be any real number associated with it. Infinity, it just means you keep on going. It's not an actual number. And the really sad thing about this is you can't even say that it goes to infinity, because if you approach 2 from the left-hand side, what's it doing there?
It'll go down to negative infinity.
Right. So there's no single value that this actually goes to. It actually goes to 2 different values, if you will. It's just that, in fact, it never stops. So we'll talk about horizontal. In fact, we do have a horizontal asymptote. Let me put that in as well. And for this, you're right. This, as we let x go very much to the right or very much to the left, then we will get y equals 0 as a horizontal asymptote. So that actually is correct. That we will get a single value for. And that's what we're going to talk about in limits when you take pre-calc or calc, especially pre-calc. What are you taking next year?
I'm taking pre-calc.
Well, you hope so.
Yeah,
we hope so.
Hope and a prayer.
Hope and a prayer. All right. I guess you better bribe me really well. All right. So what we're going to do is we're going to take a look at changing n. And right now n is 1, so this is what we're getting. This just looks, as I said, like the graph y equals 1 over x, except it's shifted over 2 units. Okay? All right. Well, let's go do our thing. Let's animate that parameter. We're going to go ahead and pick some very carefully selected values, 1 through 11, let's say, and we'll go through 11 steps of increments of 1. And that's going to make it nice whole numbers. So let's play this and see what happens. Okay. So we can break this up into 2 pieces. On the right-hand side, the asymptote is kind of staying somewhat similar. as n goes up, it does become a little bit more box-like. You'll notice that it seems to be rotating about this particular point right here. That's kind of similar behavior that we had with some of the polynomials, right?
Yeah.
We said that 1, 1 was an example of a point when we were doing the polynomials that would it would always go through that point. In this case, because we've shifted it over 2 units, it's actually now 3, 1 rather than 2, 1.
1.
Sorry, rather than 1, 1. Thank you. My students love to correct me, and, well, they should. Okay. Now, on the other side, this is, again, just like the polynomials, flipping back and forth. It has an even-odd behavior. Let's go ahead and take a look now at just making the ends even. All right, so if we go from 1 to, let's say, 21, whoop, forgot to hit the delete key. We get steps at 2. Now, this is going to be the odd behavior. So now if we play this, now we're not getting that switching. We're getting that more box-like structure as n gets bigger, and then it smooths out as n becomes smaller. Okay, and we can see that, I guess the way I would describe this is the branches tend to go in opposite directions around the asymptote. That is, this branch goes off to positive infinity, this branch goes down to negative infinity. So they're going in opposite directions as they approach the asymptote. That's when n is odd. Okay? Does that make sense to you?
Makes perfect sense.
All right. Let's go ahead and pause this. We're going to go ahead now and change this from 2 to 22. We're going to again go by 2's, which means that we're going to look at all the evens. And let's play that. So again, we see the smooth to box-like structure as n goes up. And in this case, this does go off to a single value of infinity as you approach 2 from either side, from the left or the right. And in fact, in pre-calc and calc, you will actually talk about, I think actually in calc, you'll talk about the fact that you'll, I think for the first time, be allowed to talk about the limit as x approaches 2 from either side being equal to positive infinity. Okay. So this is our even behavior, and we'd also call this a multiplicity. Even multiplicity allows the branches to approach the value in the same direction. That is, they both go to positive infinity as they approach 2. And when we have the odd multiplicity, that's where we say does not exist. So there's simply no value. But the branches, as far as graphing, go in opposite directions. Okay? Do you have any questions?
Nope.
All right. Yeah, I think that about covers it. There's more that we need to cover before we put it all together, and we're going to do that in the next video. I think Cole will be here for that. We've got a little more time. So let's go ahead and pause this, and we're going to very quickly go through the ending screen. This was A Tutoring Enterprises, and we were talking about rational functions and vertical asymptotes. And that's all the good stuff about my business, the website, email. You can call me for an appointment. Cole has never come for an appointment. That's just not going to cut it. You're going to have to bribe me better than that. All right, so we got online and in-person tutoring for physics, math, chemistry, and engineering. If you need some help, give me a call or shoot me an email. What does Cole say?
Like the video.
Like the video. Cole says like the video. So like the video. Thank you. And if this was very helpful to you, then feel free to send me $1 for technical support. I want to try to get better computers and cameras and things like that. So it's also nice if I see a little appreciation from you guys. So that's my little plug for me. Right here, you're going to have a white screen where various links will start to come up to past videos, some links to future videos. The past polynomial video should be there, and all the future rational function videos should be there too, so you can kind of skip ahead if you like. Well, thanks for watching the video, and anything you want to say on the way out?
Not really.
Can't think of anything. All right. Well, thanks for watching the video, and I'm going to say have a nice day. You want to say have a nice day? No, you don't want to say. He doesn't care if you have a nice day as long as he passes advanced algebra.
You know what? Maybe I do want them to have a nice day.
Well, tell them to have a nice day.
I hope you guys have a nice day.
All right. Cole wishes you have a nice day. All right, you guys have a good one. Thank you.